Welcome to the first video from Building a Home Server series. The purpose of the server and other IT infrastructure will be camera surveillance, file server and media consumption, occasional rendering, and in-house systems monitoring and control. Not everyone likes the cloud solutions, which have limited privacy, are dependent on internet speed, availability, and having to pay for data storage on a regular basis. Not everyone likes the out-of-the-box solutions, which provide limited performance, expandability, and are very expensive. Some people like to do things their own way, and if you're one of them, then this video is for you. In the first part of this video, I'll be looking at the choice of the components and their limitations. In the second part, I'll be assembling them together into a server. Now, the following videos from this series will focus on RAID configuration, OS installation, networking, performance testing, camera setup, and other activities which are necessary to get the whole server infrastructure running. But that will be later. Before we get to the individual components, let's have a look at 7 characteristics I took into consideration before choosing them. Reliability is the most important because you want an uninterrupted service of the server and some guarantee you won't lose your data in case of any malfunction or incident. Therefore, the redundancy of key components is necessary. Mainly the hard drives, which hold the data, because if you lose them, you can't get them back unless you have a backup. And to be able to make a backup, you mustn't lose them in the first place. The longer you run any system, the higher the probability of occurring errors, so the error correction capability of memory is definitely welcome. And last but not least, the expected lifespan of components and their warranty is important when you plan on running the server for several years 24/7, because not all components are of the same quality. All this, translated into practical language, means that I'll use redundant hard drives and SSDs. I'll use also ECC memory modules and high quality components from well-known vendors with solid warranty. Performance means in this particular use case the ability to run multiple tasks at once with some headroom. It needs to be able to cover the load peaks, that means the situations when multiple users are using the server at once. It should also allow the possibility of future virtualization, which requires having enough CPU cores, enough memory and disk space. Translated into practical language, I wanted a CPU which supports PCI Express 4.0, ECC memory modules, and has enough cores. When it comes to noise, I need the server to be as silent as possible. The goal is to reach noise level, which is lower than 36 decibels, because it will be placed close to the living area. I'll be using silent fans on the cooler, case with sound dampening material, and a silent power supply and a passively cooled GPU. Costs to run 24/7 translates mainly into power consumption of the whole solution. The lower the power consumption, the lower the excess heat, which also helps the cooling. The server should consume under 100 watts in idle with all disks connected and running. When something is supposed to run for 24/7 for years, it is wise to use as effective power supply as possible, because you don't want to pay for electricity more than it's absolutely necessary. Which means that you need to use titanium level power supply. Now to the price. When you choose consumer grade hardware, the prices are significantly lower than when using the commercial solutions, and the same goes for the price of potential upgrades or service costs. You don't get the same level of reliability, but the truth is that you don't really need it for this type of use case. If you have any potential downtime, you don't suffer any financial losses, or anyone's life isn't in danger. Serviceability and expandability means to be able to exchange or upgrade components at will with least amount of difficulty or time needed, because you'll be the one doing it. You also need to think of the future upgrades, so choosing a large PC case with comfortable access to all components without the necessity of taking it out of its place is something that will make your life easier. It should also have plenty of space for additional hard drives and SSDs, a motherboard with sufficient connectivity, and PCI Express 4.0 to be future-proof. When it comes to dimensions, it has to fit within limited space. I have very limited space, which doesn't allow me to use standard server cases, which would require standard server rack. If I had more space, I would probably go for a 3U server case with 16 positions for hard drives, which would make any potential upgrades even easier. Now let's have a look at the components individually. Let's begin with the obvious, the AMD Ryzen 3900X CPU. It has the performance of 1st Gen 16-core Threadripper and a TDP of 105 watts, although it's more close to 150 in real-life conditions, especially under full load. I needed something future-proof that would last me for the next at least 7 years, and at this price point, which is currently under $450, there isn't any real competition. If I had to choose a cheaper alternative, I would probably opt for 3700X, that means 8 cores, 16 threads, but I really wouldn't go any lower, because if you want to use virtualization, there is really no substitute for not having enough cores. Every CPU which is supposed to run 24/7 operation needs a good cooler. This Noctua NH-D15 SE-AM4 is one of the best air CPU coolers available on the market. As you know, I tested it against Zalman a few weeks ago and it proved to be a worthy competitor. It has solid performance while staying very quiet, and the Noctua fans are known for their reliability. I have some in my other PC which have been running there for almost 8 years without any problems, so that's definitely a good thing. This cooler has 240mm fans and a large heatsink. It probably won't fit into every case, so make sure you check out the dimensions before making any purchase decisions. It's cheaper than most of the water coolers, but more expensive than most of the air coolers. For a server, most important thing is reliability, so I prefer something which would be just spinning over something else which would be both spinning and pumping liquid at the same time. The water pumps have limited lifespan and the liquid can leak or potentially dry out. When I was choosing a motherboard for the X570 platform, there was a wide choice. One of the better equipped motherboards was this Gigabyte X570 Aorus Master, which has solid 14-phase VRMs for powering, that's likely to long last, and a good connectivity. It has 3 PCIe NVMe M.2 slots and 2 Gigabit LAN cards, one of them potentially 2.5 gig, depending on the rest of the capabilities of the network. It has, of course, PCIe Gen 4 slots, which make it at least somewhat future-proof, but rest of the capabilities like the RGB controls or high-quality audio are completely irrelevant for this use case, because it's going to be locked into a case which has no windows and into a custom rack which also has no windows, so it will be completely invisible. Most servers in data centers use ECC memory modules. Since this is going to be a server, although running at home, I'm going to use them. I know that it's going to be at a cost of performance, because the Ryzen chips perform best when their memory modules are set to 3600 MHz. The fastest memory modules I was able to get for this motherboard were these Crucial 2666 MHz DIMMs running at CL19. If you ever decide to go for ECC memory modules, make sure to check out your motherboard manufacturer's compatibility list before buying. When I was looking for a GPU for this server build, I had two main characteristics in mind. First, it should be completely silent, therefore passively cooled, and second, it should have low power consumption at idle. After meeting them, I was looking for a GPU which had 4K output capability. As you see, I ended up with Palit GeForce GTX 1050 Ti, which I already have a good experience with from my other PC builds, so that's why I opted for it. There is also a 1650 version of this one, and it's probably 30% faster, so that's another option. I covered the thermal characteristics of this one in my unboxing video, so if you're interested, you can have a look at it. Other than that, when I was choosing these passively cooled GPUs, I found out that there really isn't a wide choice on the market, so I opted for something I have a good experience with. One of the most overlooked components in PC builds are power supplies. Since this is going to be a server running 24/7 operation, the power efficiency and stability are the keys. As you see, I ended up with Seasonic Prime Ultra Titanium 650 Watt version power supply, which is able to achieve 93% efficiency at loads around 100 watts and stay silent up to 40% load. Although this is a high quality PSU, there is going to be only one in this build, so there is no redundancy, which makes it a vulnerability. It will be fed with line interactive UPS, so hopefully it will stay live for the next 7 years. Data are the most important asset on a server, therefore I have decided to protect mine with RAID 1 configuration. The advantage of this solution is that in case of a drive failure, you can swap the drives easily without waiting for the long array rebuild like in other RAID configurations. There will be one exception, and that is this Crucial MX500 drive at 2 TB capacity, which I'll use for temporary files only, therefore no redundancy is needed. For OS installation, I have decided to go with Corsair MP510 drives at 480 GB capacity because of their endurance. Normally, I would have gone with Samsung 970 Pro drive, which is my favorite for OS installations, but in this case scenario where the data need to be written continuously into a database, the durability is more important. These drives have 800 TB writes durability and this one only 600. There is of course a performance difference. Samsung's faster, but also a price difference. These drives cost almost half as much as this one. So in this case scenario, the durability is more important. For the standard files, I have decided to go with Seagate Iron Wolf drives at 6 TB capacity, which are standard for NAS installations. When it comes to surveillance drives, I have decided to go with Seagate Skyhawks at 4 TB capacity, which I already have a good experience with from previous installations, so I'll use them again this time. When it comes to future expandability of the server, I've decided to wait because there still isn't any PCIe Gen 4 controller on the market, and since I have a PCIe Gen 4 capable motherboard, I'd like to use it, so I'll wait some time and see what happens. Because of the space and noise limitations that I have, I couldn't use a standard server case. Standard server cases usually need to be mounted horizontally, like this one, and they require a rack for placement. I have only 35 centimeters from the wall and I need to put it on a shelf, so I decided to go with standard PC case, In this case, Nanoxia Deep Silence 5 Revision B, which has 11 3.5-inch drive bays and uses 340mm fans for cooling and a sound dampening material to keep it all quiet. I think that's it for the choice of the components for this build, so let's get to it. I have decided to do this part of the video in a detailed style, so that even people who have never assembled a PC before can make use of it. There are a couple of things that need to be done before we begin with the assembly, and that is to make things easier and safer. The first one is getting rid of the boxes. That means unpacking the case, CPU, GPU, power supply and the CPU cooler. Make sure to keep all the accessories which were included close by, because we'll need them. The manuals can be kept separately, because we'll need only some of them. By getting rid of the boxes, I don't mean destroying them, because we may find out that some of the parts are DOA or don't work properly and need to be returned to the seller. So for this case, the boxes need to be kept intact until we find out everything's fine. The second thing we'll need is a monitor, keyboard and a mouse, because after we put the components together, we'll need to get into the BIOS and find out whether they work. Next thing is a paper bin. We'll need it after the installation of the CPU and the cooler, because we'll be using these paper towels for cleanup and we'll need to dispose them. The third thing we'll need is to make sure of the safety. You'll need 5 things: quality electric outlet, which is grounded and ideally has surge protection, ESD bracelet, ESD gloves and ESD mat. ESD stands for electrostatic discharge. It is to protect you from discharging your body electricity into your components, because you might damage them permanently. The gloves are also for your protection, because the case and the heatsink of the cooler may have sharp edges and you might cut yourself. Also, you don't want to have fingerprints all over the components and case. And the last thing is this plastic mat, which you can buy for $1 in Home Depot or similar shops. And it is to protect you from scratching your table by the case. So when you pick something ideally which is electrically non-conductive. The fourth thing we'll need are these tools. These are necessary and these are voluntary. The most important is this Phillips head screwdriver with magnetic head, and that's for screwing any screws during the installation, except for one situation, and that is installation of the M.2 SSDs. That's what this smaller one is for. This blade is for cutting any plastic straps or sags. A long Phillips head screwdriver was part of the accessories of the CPU cooler. That's for its installation. The flash drive is for installing the new BIOS into the motherboard, because all the motherboards come with old BIOSes. This one is 32 GB, but 8 GB is fine, or even smaller. Now, these tools are to make your life much easier. I am all about comfort during the installation, so whenever I encounter anything that can make my life easier, I start using it. This small screwdriver is something that I use for opening stuff instead of my nails. This Phillips head screwdriver, small one, is for untying the thumb screws on the back of the case. This is a magnet, so whenever I drop any screw inside the case or anywhere else, I just pick it up with this one. Then this tool, in combination with this 5mm nut, is for tying the standoffs for the motherboard into the case. Really makes ton of difference. These clippers are for cutting any cables or plastic straps. The electric screwdriver in combination with this magnetic bit holder, that's a deadly combination. Once you start using it, you can't go back, so I can't go back. The extension for this magnetic bit holder is something that I use when I can't reach somewhere. The scissors are for cutting any plastic sacks or straps or paper, just anything, when it's easy to do with it. And the plastic sacks are for the installation of the CPU. I use it when installing the thermal compound on the surface of the CPU, so we'll need just one of them. The last few things I haven't talked about and which are on the table is this plastic organizer box, which I use for unpacking all the screws from original sacks, and this tray, which I used for unpacking the screws from the original case accessories to make it easily accessible. And when it comes to the cables from the power supply, I left inside this original sack only PCI Express cables because the graphics card doesn't have PCI Express connector. One last thing before we begin: do not use any excessive force during the installation and do not over tighten the screws. The components are very fragile. You'll also see me using this electric screwdriver a lot. So if you decide to use it as well, make sure to check your torque settings first and try it on something else which is not so fragile before you begin using it. Now we can begin with the installation. The first thing I'm going to do is to remove my watch, because I won't be needing it. And second thing I'm going to do is to take the gloves. We won't be needing these cables because these are PCI Express, and as I mentioned, the graphics card doesn't have PCI Express connectors, so I'll take it away. The first thing we need to do is remove both side panels of the case so we can get inside. To do that, I'll unscrew these thumb screws and remove the side panel. The same thing here. Now that we have the case fully open, we can install inside the power supply. It will act as a grounding device, so that's why we are doing it first. Before we proceed with the installation, we will test it with a supplied power supply tester, which was included in the accessories. Not all power supplies have this included, so you might not be able to do it if yours doesn't have it, but this one does, so we'll do it. To test the power supply, we will need a 24-pin power cable, which is this one. I put all the other cables away. We will also need this power cable, so I will untie it and connect it to the power supply. There is only one way of doing it, and that is this way. I'm also making sure that this switch is switched off and this other switch, which switches the power supply into hybrid mode, is switched on, which means that it's in normal mode, because in hybrid mode it doesn't work. So now I'll connect the 24-pin power cable. There is only one way of connecting it. There are these notches at the back, so I'll plug them one by one. And now we will need a power supply tester, which was included in the accessories. It will be connected to this 24-pin. I'll take it out. It looks like this. There is also only one way of connecting it, so we will find the notch on the power supply tester and on the 24-pin and connect them. It clicks in nicely, and now it's ready to be tested. To do that, we will need to plug it into electricity. So let's do it now. Now I'll plug it in. I'll switch on the power. And as you see, the fan started spinning, which means that it's working. Now I'll switch it off because we know everything's fine. And I'll unplug the power supply and we can start using it. Before we can install the power supply into the case, we need to remove this main power cable. And also what we need to do or want to do is to connect all these power cables, because it would be difficult to do it after the power supply is inside the case. So let's do it now. Now we can connect the modular power cables. We will begin with the Molexes. The Molex power cables look like this, just for you to know what we are connecting. They are used for powering older components. The part which goes into the power supply is this 6-pin. It is unlabeled, but we know that it's Molex, and Molex is also on this label on the power supply. We will begin from this side, so I'll connect it. There is only one way of connecting it, and that is with this notch down, so you can't do it wrong. This is another 1x2 Molex power cable, so I'll connect it next to the first one. Now these are SATA cables. They are usually used for powering the hard drives. In the past they were used for powering CD, DVD and Blu-ray drives, but nobody or not many people use them anymore. Generally they are now used mostly for the hard drives. Also I'll use the 6-pin connector to connect it to the power supply. I'll do that. I'll move it away for now. Now this is a 1x2 SATA power cable, so that's the last one I can connect there. What you see here is a Molex to SATA reduction cable. I'm not sure whether we will need it, but if we do, we will need it later, so I will put it away for now. And last but not least are these CPU power cables. The part which is connected to the power supply is the one which says PSU, power supply unit, and there are these 4 connectors I can connect it to, so I will start from the ones which are down. The part which goes to the motherboard is the one which says CPU. There are these 2 4-pin connectors which are connected to the motherboard as one, but some motherboards don't require 8-pin, just 4-pin, so that's why they are divided. The last connector I'm going to connect to the power supply is this one. And now everything is ready. We can move to the next step. Before I place the power supply into the case, I'll remove these cables away so that we have comfortable space for it. Also the ones which are for powering the fans. Then I'll remove these stickers because there is really no need for them. So I'll use this screwdriver Now I'll place the power supply inside the case. There are these rubber stands. Really, there is not too much space, but I'll manage. Now it's sitting there comfortably. There are a few important things you should know about power supply placement. If you have a semi-fanless power supply, like I do, it is better for it if it's placed top cover upward, that means facing the motherboard, because the natural dissipation of hot air is upward. If you have a passive or passively cooled power supply, you must position it this way, otherwise it will overheat. If you have a normal power supply, that means the fan is spinning all the time, it would be better for it if you turn it the other way around, that means the top cover facing the bottom of the case, so that it could suck the cold air from the bottom and cool itself even better. But you must make sure there are holes in the case, otherwise you would choke it. And the last tip is that if you have a heat generating component like the graphics card or RAID controller, especially in the last PCI Express slot, you could help cooling it by having this power supply placed this way, because it could suck the hot air from underneath it outside. The first thing I'm going to do is to check if the holes inside the case are aligned with the holes inside the power supply for the screws. Then I'll take the screws which were provided with the case and screw them in. And now it's finished. Now I'll check if the power supply is still switched off. It is. So I can remove the power supply tester and connect the power cable. And now I can plug it into electricity. The case and the power supply are now grounded. Now it's time to ground the mat. I'll connect it to the case using these alligator clips. So it should be easy. The mat is grounded now. Now I'll ground myself. So I'll use this strap. You need to make sure that this metal part is touching your skin, otherwise it wouldn't work. And also make sure that it's tight enough, that it's really touching your skin. And the last thing is you need to make sure that this is turned towards the part you're going to be grounded by, in this case the case. So now I'll connect it, and I am grounded now as well. During the installation, what may happen is that I'll disconnect myself because I also need to operate the camera. But when you are going through the installation, you should be connected at all times. Now it's time to have a look at the motherboard, because we need to prepare it for the installation. The keyboard and the mouse can stay on this table because we will be needing them, but later. Now I'll take both the motherboard and this box, because we will need the box as well. And I'll remove the motherboard from this box. I'll try to do it gently. and put the box on the box of the motherboard right now, but soon we will need it. Now I'll turn the case to its back, making sure that I don't scratch the table. Now we can see inside the case nicely. First thing, we need to check if there are any pre-installed standoffs. As you can see, there are no pre-installed standoffs, so we will need to use our own, which were part of the accessories of the case. In order to know where to place them, we will need to look at the motherboard and check it. I'll take it out of its sack. The motherboard has 9 holes for the standoffs. Every ATX motherboard has 9, so there is really no difference. You'll also need 9 screws to screw them in, but before we do that, we need to check if the motherboard has a pre-installed I/O shield. This one does. Otherwise, you would need to install this I/O shield before placing it in. There is a space for it. And also, when you're holding the motherboard, make sure you're holding it by the edges and you have gloves so that you don't leave fingerprints on it. Now I'll slide it in slowly and carefully at an angle, which makes it easier, and it slides into the hole. Now I can see where the standoffs will be placed, so I can take it out now and we can begin with the standoffs installation. There are several ways of installing the motherboard standoffs. One of them is trying to screw them in by hand, which I do not recommend, but let's try it for once. I'll take it and try to screw it inside the hole. Now it goes only to a certain degree. I can't fully put it in. I'll try the tool that the case manufacturer provided, which is this. Yeah, that goes easier, but I can't still fully screw it in. So I'll try to use a screwdriver. Yeah, and now I can fully tighten it. This is handy, but not all case manufacturers provide it, so you may need to use other solution. And I'll try the second one. This one is a little bit easier. For this one, I wouldn't need anything. Let's try the next one. Now, this one is more difficult. It doesn't want to go in fully. So what I'll do, I'll use this tool with combination with this 5mm nut and screw it in. In my opinion, that's the most comfortable way of doing it, because I have the most amount of torque in my fingers. Yeah, this is absolutely the best way to do it. So I'll continue with the rest. Now it's finished. Now I'll check if the motherboard fits in without any problems. It takes just a few seconds and it's worth trying, so you know everything's ready. So I'll slide it in gently, making sure that I'm not dragging the motherboard by the standoffs. I'm trying to align this last row with the standoffs, and I can already see that it's fine. So now I'll take it out and we can start the installation of the CPU. Before we begin with the CPU installation, I'll remove this plastic and I'll look to the back of the motherboard to see if there is a original backplate pre-installed. It is, because you'll need it for the installation of the Noctua cooler. Next thing we'll also need is to remove these 4 screws which are holding these 2 plastic brackets, because we won't be needing them. Now it's removed. Now I'll install Secufirm2 mounting system for the Noctua heatsink. Now I'll take the standoffs and put them on top of the holes of the backplate. And I'll take these mounting bars and put them on top of them. I'll make sure that they are put this side, and I'll use the screws. I'll tighten the screws. And this part is finished. Now we can start with the CPU installation. It is the most delicate part of the whole PC assembly. First thing we need to do is to take this lever and put it upwards. It opens the socket for the CPU. Now I'll take the CPU and take it out of its cover. When you're holding it, you need to hold it by the edges. And when we look at it closely, you can see that there is a little arrow in the corner, and it tells us that we should position it arrow to arrow. One is on the CPU socket, so that's how we should put it in. No force is necessary. As you see, it didn't make even a sound. Now I'll try fiddling it. Doesn't fiddle at all. And now I can close the CPU socket. The CPU is now installed. Now we can install M.2 SSDs. I'll do a little unboxing. Before we begin with the installation of the SSDs, we need to make sure we have standoffs and small screws for them. They were part of the accessories of the motherboard, so I'll bring it. These are the standoffs and the screws. We'll need them now. First thing we need to do is to remove these two heatsinks, which are held by these two screws. And to remove them, we'll need this small Phillips head screwdriver. And I can remove the whole heatsink, including the screw. On the back side, there is a covered space which is for better conductivity, but we will not use it yet because we don't know if the M.2 SSDs are working. So we will install this part later. This one is still holding. M.2 SSDs come in several sizes. This motherboard supports in these two sockets sizes from 2242 to 22110. 22 is the width of the drive and 110 is the length. It's both in millimeters. These are 2280s, that means these are 22 millimeters wide and 80 millimeters long. So we will need to install these standoffs into this hole which says 80 because they are 80 millimeters long. Now that the standoffs are installed, we can put the M.2 SSDs into their sockets. Each M.2 SSD has a connector which has a key. So I'll show you what I mean. The key of the SSD is this part of the SSD. This is an M key, that means this is how it looks. The notch is here. There is also a B key which has notch here, and also an B and M key which has two notches. These are the M key, so there is only one way of installing them, and that is this way. I recommend putting them at an angle inside the socket. As you see, it's fully in, and now I'll press here. Really, it makes no resistance at all, or almost no resistance. Now I'll take the small screw and screw it in. Do not use any excessive force. When it stops going, don't turn anymore. And they are installed. Now when we're zoomed in, you can clearly see the notch on M.2 socket and how the M.2 SSD is installed. Now I'll clear the space for thermal compound application on the CPU. What you'll need are these towels, because there is always a mess. You'll also need one plastic sack, and of course the thermal compound. There are many ways of installing the thermal compound on the CPU. Most common is the one where you make a little dot in the middle and put the heatsink on it, and it will spread. The disadvantage of this method is that you don't know exactly how much thermal compound you'll need. So if you put too little of it, then it won't be enough and the thermal conductivity will suffer. And if you put too much, then the thermal compound will fall over the CPU and make a mess. The method I'm going to show you today, I call the dipping method, and we'll be using a plastic sack for it. It's one of the most accurate methods of application of the thermal compound, and the advantage is that you can put only as much of the thermal compound as it's absolutely necessary, and you have absolute control on how it's spread on the surface of the CPU. To spread the thermal compound on the CPU, I'll use this plastic sack and put it on my hand to make sure I don't get dirty. And I'll use my finger to spread it all over the surface of the CPU. So let's start doing it. Now you've seen it in real time. It's fully covered. I really don't need to make sure that the surface is completely even, because that's something the pressure of the heatsink will take care of. But this is really the result, and it took, I don't know, a minute. Now what I'm going to do is to put this inside the sack, and I'm absolutely clean and the whole installation is finished. Before we begin with the RAM modules installation, we need to make sure of two things. First, if the sockets are open, this is closed, this is open, so they are open on both sides. We'll be using a dual channel memory setup, and there is a scheme on the motherboard and also in the manual that tells us that if we are using only two memory modules in dual channel, we need to use sockets A2 and B2. That means these two sockets. So let's do it. How do you position them inside the socket? There is a notch here and the notch on the RAM module. We will make sure that those two match. I'll need to turn it this way and insert it in the socket. There are these spaces especially for it, so I'll put it in gently. It falls in without any problems, and now I'll press from both sides at the same time. I'll press firmly. And you heard the click. I'll do the same thing with the other RAM module. And the memory is installed. Now we can install the Noctua heatsink, so I'll bring it. On the bottom of the heatsink there is this plastic cover, so I'll remove it. And you can see that there are these two captive screws. I'll make sure that they'll be aligned with these two screws on the mounting bars on the socket. It doesn't really matter if I put it this way or the other way. They are exactly the same, so it doesn't make any difference. And I'll try to put them as accurately as possible on those screws on the socket. And that's the first step. To screw those captive screws into the mounting mechanism, I'll need a Noctua provided screwdriver, because it's long enough to reach in between those two towers. I'll be screwing them in alternating fashion, that means 2 rounds each, until I reach complete fixation. I'll use my second hand to hold the heatsink. Now the second one. And this one. And now it's finished. Now we can begin with the fans installation. Before we do that, we'll look at the motherboard. Here are the CPU fan headers. So when we are attaching the fans to the heatsink, we'll make sure that they are positioned, that their power cables are close to these fan headers. Second thing we need to have a look at are the positionings of the memory modules. We'll need to put the fan from this side of the heatsink so that it doesn't touch the memory modules. And to do that, we'll probably need to reposition the fan clips upwards. Now we can begin with the installation. This fan didn't come with the fan clips attached, so we'll need to attach them. It's really easy. Now the other side. Now it's prepared. This side of the fan is the one which sucks the air from the inside, and this one blows it away. Now I'll put it in between these two towers, making sure that the power cable of the fan is on this side. And yeah, I'll use the clips to attach it. It's really easy. And now I'll do the same thing from the other side, but this fan will be risen higher. Now we can have a look at the installation. You can see that I have risen this fan higher above the memory modules. These are with low profile, so I can even put this fan lower if I want to. And now it's ready. The last thing we need to do is to connect this PWM fan Y cable to the motherboard header. It will allow us to power both fans by one connector. There is only one way of connecting it, and that is through this 4-pin connector. Now I'll attach it to the motherboard header. And now I'll connect both 4-pin connectors. And it's finished. Now we need to test if everything works properly, but before we can do it, we need to install the graphics card. And to do that, we'll use the box which was inside the motherboard box and turn it around and put this motherboard on it. We need to be careful because it's heavy now. Now I'll turn it around and I'll take the graphics card. I'll also make sure that this part is aligned with the end of the box because the graphics card will overlap. Now the graphics card has this PCI Express connector and we'll put it into PCI Express slot. There is only one way of putting it there, and that is this way. And before I can do it, I need to make sure that the slot is open. So now it's closed and now it's open when I pull it down, and I will carefully insert the graphics card in it. Now it's in. I'll press gently and it's in. I'll let it lean as it is, but I'll not make any force because it's holding just, but it's enough for us to be able to get into the BIOS and test if everything works. Now I'll pick up the case carefully and put it on its legs so that we can connect the power cables to the motherboard. I'll make sure I'm not putting it on the cables. And I'll reattach. Now we need to plug in the keyboard, mouse, monitor and the power cables. I'll begin with the keyboard. It has a USB port. If you turn it this side up, that means with these two holes, you can connect it to the port on the motherboard. So I'll do that. Now I'll connect the mouse, exactly the same thing. Now I'm going to connect the monitor. It uses a display port. This is how the display port looks like. So I'll plug it in. And now I'm gonna turn around the motherboard so that we have better access to the power cables. First thing I'm going to connect are these power cables. These are the 8 pins for the CPU. There is only one way of connecting them, and that is this way. So I'll put them together and try to put them in. And I'll do the same thing with the second 8-pin power cable. also put them in these notches together. Now I'm going to connect this 8-pin. So I'm going to turn the motherboard again. And I'm going to use this 24-pin power cable. Also only one way of connecting it in, and it is this way. And everything is connected, so we can get into the BIOS. Now I'm going to switch the power on the power supply and the monitor and the power on the motherboard. So let's do that. And the power here, as you see, it lit up red. And it looks like we are running. We'll see if anything shows up on the monitor. I'll be pressing delete so that we can get into the BIOS. And I'll also need to check if the output on the monitor is set to DisplayPort. So I'll go to DisplayPort on the monitor. And do we see anything or not? Looks like something is happening. Sometimes what happens is that first time you insert the memory modules, it loads up and then it resets again. And that's exactly what happened now. So now it's asking for the boot device. I didn't press delete in the second run. So I'll press Ctrl Alt Delete to reset it, and I'll keep pressing delete now until we get into the BIOS. So the sound suggests that we have just restarted and we are in the BIOS. Now it says that the BIOS has been reset. Please reconfigure your BIOS setup items if needed. Of course, because this is the first run, so we'll need to load our optimized defaults and check everything. Now that we are in the BIOS, we want to check out few things, especially if the components that we installed are present, and that's the sign that they are working. You'll be able to check if they're working really properly after we get into the OS, but this is just a basic checkup. For the overview, it is best to go to the easy mode. You can press F2 or click easy mode, and we can see that the BIOS on the motherboard is version F11. It is a new version of the BIOS because I installed it there. I'll show you later how to update the BIOS. The new BIOSes usually increase stability and compatibility with the components, and this BIOS increases the compatibility with the RAM modules, and it also improves the behavior of the chipset fan. That's why I installed it. It's always best to have the latest BIOS. The CPU installed is Ryzen 9 3900X. RAM is 32 GB. Under it we can see that there are two modules installed. They are made by Micron and they are 16 GB each, running at 2666 MHz. Both SSDs are installed as well. MP510 drives. The CPU fan is running at 800 RPM and the one on chipset around 1700. If you can hear me, you can also hear the whole computer because it's 30 centimeters away, so it's pretty quiet, and that's what we wanted. Last thing before we power down the computer, we want to load the optimized defaults, because that's the starting point before you begin doing anything else in the BIOS. So I'll click load the optimized defaults and I'll press yes. Now it's loaded, it's really quick, and I'll press save and exit, and it will restart and start booting again. So now the computer is rebooting. It will try to boot from those drives, but there is no OS installed, so it will show up soon. Yeah, reboot and select proper boot device. So this is exactly what I expected. Now I'll switch off the power button on the motherboard and we can continue with the installation. Now that we know everything's working, it's time to update the BIOS. We'll need the flash drive, which we prepared at the beginning of this installation. We'll need to plug it into another computer, and I'll show you what to do next. Now I'll insert my flash drive into USB port. As you see, it appeared on the screen. What we need is a flash drive which is formatted to FAT32 file system. I'm going to check it by right-clicking on it and choosing format. It shows me that the drive is formatted to NTFS, so it will need to be formatted. If you have any data on your flash drive that are valuable, make sure to back them up before continuing. Now I'll choose FAT32 as a destination file system, and I'll press start to start erasing the data. It will warn me that it will erase all the data on the disk. I'll press yes, and now the formatting is complete. When I close the window and take the drive from the USB port and put it back in, it shows me that the drive is formatted to FAT32. So now it's ready for the BIOS update. I'll go to Gigabyte's website, click on Products, then choose Motherboard. Then I'll go to Downloads, and here I'll select the socket AM4, and then I'm going to select the chipset, which is X570. Now I'll type in Aorus Master, which is the name of the motherboard, find it and click on it. Now I'm going to go to Support and to BIOS. It will show me several BIOS versions. The latest one is F11, so I'll click Download to download it. It will allow me to open the file, so I'll do it. And using File Explorer, I'll open it and copy the x570ama.f11 file to my flash drive. Now it's copied there, and as you can see, the file is ready for the BIOS update. The latest BIOS is now on the flash drive, so I'll unplug it and I'll plug it into any USB port on this motherboard. So I'll choose, for example, this one. Now I'll switch on this computer and I'll keep pressing delete until we can get into the BIOS. Now we're in the BIOS, so I'll show you what to do next. Now that we're in the BIOS, we can go to easy mode. We can click on it or press F2, and we can see that the actual version is F6. For this use case, I downgraded the BIOS to F6 so that we can see how it's upgraded to F11. Then we'll go to QFlash. We can click on it or press F8. And here is a possibility to update the BIOS. So I'll click on it. And now it shows us what's on the flash drive. We can see that there is this X570 AMA.F11. That's the file which contains the latest BIOS. I'll click on it and click on this arrow. Now it asks us if we want to update the BIOS. I'll click yes. And now it is waiting for us to give it command to start updating. We can click on start, and now it's updating the BIOS. Now it will automatically reboot. So this is what happens when you update the BIOS and it restarts twice. It will try to boot into any operating system, but there are no OS installed. So I'll press Ctrl+Alt+Delete and we can have a look into the new BIOS. I'll keep pressing delete so that we can get there. Now we are in the newly installed BIOS. You can see that it says version F11. Everything seems to work fine. Here is the flash drive and 2 SSDs. Now I'll click Load Optimized Defaults because that's where you start. I'll click Load Optimized Defaults, yes. Now it's loaded. So I'll press Save and Exit and I'll confirm. Now it restarts again. Now I'll hold the power button on the motherboard for a few seconds and it will power down the computer. The latest BIOS is installed now, so we can switch off the power supply, unplug the flash drive, and also unplug all the cables which are connected to the motherboard and the graphics card now, because we'll prepare it to be put inside the case. Now I'm going to disconnect the graphics card because we will need to get to the M.2 SSDs so that we can install the heatsinks on them. Now we need to remove the stickers from the SSDs. And now we can install the heatsinks. Now I'll take the heatsinks, remove the protective material and place them on the SSDs on the socket. I'll make sure that each heatsink goes to its original position because they are not exactly the same. Before we continue with the installation, what we need to do next is to check if there aren't any leftover plastic on the motherboard, because it would prevent the heat dissipation and it would be difficult to remove it after it's in the case. And the second thing we need to do is to take the power cables, two 8 pins and one 24 pin, and put them through the holes in the case and prepare it for the motherboard's installation. And now it's ready, so we can take the case and put it on its back. Now I'll reconnect the power cable, making sure that the power supply is still switched off. And I'll also reconnect my bracelet so that I am grounded. Before I'll place the motherboard inside the case, I'll put there this piece of plastic which I cut from the mat it is sitting on, and it is to prevent the motherboard from scratching, because I'll not place it on the standoffs right away. Now I'll place it inside the case slowly and gently, making sure that I am not scratching anything. Now that I have more space for my hand, I'll connect the 8-pin power cables to the motherboard. Now the 8 pins are connected, we can take the plastic from underneath the motherboard. Now we can place the motherboard into its final position. We are making sure that the standoffs and the holes in the motherboard are aligned. Now I'll take the motherboard screws, which were part of the accessories of the case, and screw them inside the holes. And it's finished. Now we can connect the 24-pin power cable, which is this one. Now it's time to connect this 140mm fan. It uses this 3-pin power cable, and I'll connect it to the case's special cable, which can power up to 3 fans, which are manually controlled from the front panel of the case. I will leave it like this for now, but I'll tidy the cables later. Next in line for connecting are these two 140mm fans power cables, which are at the front of the case. I'll connect them to the second circuit of the case, which can also power 3 fans at once and which can be manually controlled. While there is no graphics card installed yet, we can use this opportunity and connect the SATA cables. With the motherboard, there were these 4 SATA cables provided. I'm adding these 2 because I have 5 SATA hard drives, and I'll use 3 of these and these 2. I'll connect these 2 to the surveillance drives. I'll start from these connectors. The way you connect it is this way upward, and I'll start from the bottom one. And now the last one. To connect the cables from the case, it is best to consult the manual, and using this scheme and the provided G connector, which was part of the accessories of the motherboard, I'll connect them to this header. If you are wondering how to connect the cables to the G connector, there is a arrow here which signifies plus. Then you can look at the G connector, find the plus here, and you know how to connect it. And it clicks. You do the same thing with other connectors. I have connected the cables to the G connector, and now I'll connect the G connector to the motherboard header. There is only one way of connecting it, and now it's in. Now I'm going to connect USB 2.0 ports. One of the connectors is filled, so make sure you don't force it into the header and insert it in the right way. Now it's connected. Now I'm going to connect the last USB 3.0 cable, which will be connected to the motherboard from the case. There is also one space which is filled, which is this one in the corner, so make sure to put it in the right way. And now it's connected. When it comes to HD audio cable, I am not gonna connect it because this PC is going to be a server, so no one will be listening to any music, so it wouldn't make sense. But if I wanted to connect it, I would put it into this port here. To power 3 140mm fans from the case, I'll use this Molex connector from the power supply. I'll connect it to this power cable, which is from the case. It powers all 340mm fans, both circuits, and I'll connect it this way. There is only one way of connecting it. Sometimes what you need to do is to look at the positioning of these two cables inside and make sure they are perfectly aligned with the connector. Sometimes it takes longer. That's why not many people like Molexes. Before we can install the graphics card, we need to remove these two slot covers because the graphics card is dual slot. Now I'll place in the graphics card. I'm going to position it this way down into the slot, and I'm also making sure that these notches go in here. I'll slide it in gently, press, and it's in. Now I'm going to tighten it with the screw. And I'll use the second one as well. Now it's secure. Now we can take the case and turn it to its vertical position. We need to do it carefully. Now I'm going to unpack the hard drives. Part of the accessories of the case were these screws for 3.5-inch hard drives and these mounting frames. I'll place the hard drives into the mounting frames and screw them in from this side. Let's do it. I'm going to make sure that the holes of the mounting frame and the holes of the hard drive are aligned. Now I'll screw it in. I'll use these screws for 2.5-inch drives. Now that the drives are ready, we can start placing them into the drive base inside the case. Now we can connect the drives. I'll begin with an SSD and place it into the top of the drive bay because that's the space where the 3.5-inch drives can fit only with difficulty. So this is the best way to use it. I'll press and it clicks in. Now it doesn't have to make this sound, so when I put another drive in, I'll use these clips. And now I'm gonna load the rest. The drives are loaded now, and before I start connecting them with the SATA cables and the power cables, it requires a little bit of thought, because you don't want to have the cables crossed or not being long enough. So I tried this ahead of making this part of the video, which is the best configuration, and I found out that the best way to connect them is starting from the bottom to the top and starting with SATA connectors. So that's where I'm gonna start. Now the bottom drives are the surveillance drives, so I'll use these yellow SATA cables. It was my choice, it's not something that's necessary to do. Now I'm gonna connect the iron walls. I am now going to use these 90-degree connectors. And the last is the SSD. Now I'm gonna use these power cables, and I'm going to begin with this small one, and I'll put it into this drive. I have measured the length of this cable so that it can power even the drive which would come underneath it. And this power cable has 4 connectors, so I'm gonna use it for the rest of the drives. I'll start from the bottom as well. Drives are now connected, but you can see that the cables are overlapping, so I may need to press them inside a little bit, and I'll also do some cable management so that it's more tidy inside. But overall it's really not bad as it is right now, so the adjustments will be very small. There is another thing I want to talk about, and that is the positioning of the connectors of these drives. I position them this way on purpose. Normally they should be turned the other way, but I want to have full access from one side, not only to be able to take the drives out for service reasons, but also to connect and disconnect the connectors. If I put them inside the other way, I would need to have both side panels of the case open when servicing them, and that's exactly what I don't want. So this is optimal. This is how it looks without any special cable management, just how we did it. I put 2 cables different way, but that's all. Now I'll do a few tweaks. I don't think it requires me to explain it. You may do a better job than me when managing the cables. Just the goal is to make this space without any cables, so that the airflow can go to the cooler. But other than that, there is really nothing special about it. I'll use these Velcro straps which were provided with the case and the power supply. They might be handy. It's good to use these instead of the hard ones, because you might want to reposition the cables later, and you won't need the clippers to untie the cables. Also, at the back of the case there are 4 holes which I'll fill with these rubber covers. I'll try and show you. These rubber covers, that's like a minor thing, and when it comes to the back of the case, really not much cable management is necessary. I may tie these two cables to this back panel, but that's all. This case is one of the best when it comes to the inside positioning, so that's why I chose it, and it was one of the easiest installations I have ever done inside this case, so I can really recommend it. And now I'll do the cable management. This is how the final result looks like. As you can see, not many changes were made. I used 7 cable straps to tie the cables together, and I bent these cables so that I can close the case. When it comes to expandability, I have several options. I can put a special reduction so that 4 more 3.5-inch drives could be added here. This drive cage can hold 6 2.5-inch drives or 3 3.5-inch drives horizontally, and here I can add 3 more 3.5-inch drives. Now there is plenty of space for airflow, really no obstructions here, which is the goal, because airflow is necessary to keep the temperatures down. When we look at the back, you can see that I used 4 straps to tie the cables to the back of the case. The area for hard drives is very clean, no obstructions for airflow and no cables even here. These 2 cables are for 240mm fans, which are at the front. I'll show you how they look because we didn't go through this. They are also very easily serviceable. I just press. Like, I wish all the cases had this possibility, so I'll show you. You just open the door for it and you can get to the 140mm fans and exchange them. So now I'm gonna close it. And that's pretty much it. What I wanted is something that is easily serviceable. Really, looks are not important. It will be closed in a custom rack and not be visible at all. So really, something that doesn't require hard work is the goal. And it's finished. The first part of this series is over, but next one is coming. In the next part, I'll look at RAID configuration and OS installation. I'll go through several scenarios which are important because you need to know how to service the server when there is some failure or something bad happens. In other parts of this series, I'll look at networking, camera setup and other activities which are necessary to get the whole infrastructure running. That's especially for those who skipped the intro and went to the build itself immediately. And if you have any suggestions, let me know in the comments below. I'll give it a thought. I cannot promise I'll do it, but maybe it will happen, who knows. Thank you for watching, and I hope to see you next time.